afternoon. Hello? Yep.
Yeah, I wanted to get one.
Presentation. Yes.
Okay, hello everybody, good afternoon, and thank you so much for being here. My name is Arna Huerta, and I am part of the class organization team. And I'm both participating and somehow moderating the next panel, so I will first explain a couple of changes that has been on the list of speakers. As you can see in the program, the participants of this panel are Alex de Vries, Agnes Meyer-Brandis, Ingeborg Reisler, and we have to excuse Volker Stollerts, who unfortunately will not be able to join us today. He did send out some lines by email that we would like to share with you. He says, although my boys will be missing from the discourse this time, I'm sure that building bridges between islands of knowledge is the way to go in the 21st century. if we humans want to stay humans and not taken over by artificial intelligence or other discoveries with the potential to disrupt humanity. Something's wrong here, I think. Okay. For me, as science journalist, this is still Volker. For me, as science journalist, art has always been a huge inspiration, and I think artistic visioning of possible futures and thick descriptions of realities have a crucial role to play in our societal discourses about what role science and technology should play in the social fabric of tomorrow. Of course, in my opinion, the artist tries to be subjective as much as possible to present his or her worldview. A scientist, in the end, needs to produce objective knowledge, which can be observed, criticized, or disproven with further research. So we can discuss these ideas. Even Volker is not here on the round table afterwards. And instead of Volker, Sergio Krakowski will be joining us today. He was not able to be here yesterday. We saw him briefly on the screen, explaining the project that he has been developing with Octavio Schipper. But he finally managed to be here today, so we're happy about it. And now I should pass the word to our first two speakers, which is Alex de Bruys and Agnes Meyer-Brandis. But, oh, is there? Okay.
Okay, yeah. Yeah, we have a duo presentation. We worked together in the class, and we thought it would also be nice to present at the same time, to make it feel more organic, maybe also a reflection of what we actually did, and also to mask the fact that we have been given 5 minutes each. So by changing and interchanging, you won't notice that we will take longer. I work in the GBB Institute, which basically does everything from things at the molecular or even atomistic resolution, as in protein crystallography, up to organisms of the size of bacteria. We do a bit of, what are they called? Forget about it. But not eukaryotes yet. We want to move there as well. But you see everything in between. And the central theme is molecules. So what is the role of the molecules in this whole spectrum? And that's what we try to understand. And my role in that is at the very bottom of that, molecular dynamic simulations. And I want to explain a bit about the technique and then what we did in the class project. But first I want to show you my ivory tower. I have the most beautiful office on campus until maybe the new building that you saw yesterday arrives. I don't know. But at the moment I have the most beautiful building. I can look out over the Groningen landscape, which is totally flat, which is great. You can see miles and miles. But the architect also gave me an inward view. And this is what I see from my office window. I see offices all the way down to the ground floor, which is also a nice metaphor of the different levels as which you can actually look at the world around us. Okay, so what do I do? I have a computational microscope. This gives us unprecedented and unique resolution in both space and time, things that we cannot do experimentally yet. It also has a disadvantage, and that is that we cannot really, with this computational microscope, simulate things on the cellular level yet. There are basically too many particles for us to simulate this, starting from the atoms. So that's a bit of a disadvantage, but it's great. Keep gaming, keep using your mobile phones, industry will drive us to get the computational power to do that thing. And we've actually promised our colleagues that in 10 years or so, we will simulate a complete small organelle. Let's see if we make that true. I want to talk a little bit about the background of how we do this, because also it ties into, say, how you do modeling in general. Modeling starts, of course, with the center, which is the model itself. When we think of a model, we have to start by defining the building blocks. At what level do we model the world around us? And say for me as a chemist, I would start at nuclei and electrons. Basically, if I know their behavior, I can predict all of chemistry. And when we know all chemistry, we can predict all biology. When we know all biology, we can predict, well, everything. The universe, no? Correct me if I'm wrong. Once we have defined our building blocks, basically the way they interact, the forces, are the next thing to look at. And the nice thing about nuclei and electrons is that we know these forces. It's just a Coulomb force. It's one of the simplest forces in the universe. It's very similar to gravity in terms of its behavior with distance. The only difference is that the Coulomb force can be both attractive and repulsive, which gives much richer behavior than the universe. But basically, if we have that, we can predict everything, except that it's extremely expensive to model reality at that level. So we have to find more approximate ways. But from these interactions of the nuclei and electrons, we can basically deduce the effective interactions between atoms, as they are in chemical bonds, or groups of atoms, as they are in molecules. And we can get quite good approximate ways to describe the forces. Once we have these forces, we put them in a computer model, and then we basically see what things do, and they move. Everything moves all the time. I can look at this picture for hours, and since my 5 minutes have already gone, I can't show you that. But this is fascinating. Molecules are changing their behavior all the time. They do the craziest things. Nobody is doing the same thing. They're all doing different things. But together, they have predictable behavior. And this is what we want to try and find out, and then summarize and basically play with matter, influence it. We saw yesterday also, if we want to study nature, biology, we tickle the system. We provoke it and see what its response is. Well, we can do that also in our computer simulations. Okay, so the model that we actually use in our collaborative project is the model that we are famous for in Groningen. It was mainly developed by my, the group leader of the group I work in, Sievert-Jan Marink. I was fortunate to also be involved, so I'm a sort of a co-developer. So this model doesn't model the individual atoms, as you see there, but it groups a number, say 4 to 5 of these atoms into a larger entity, which nevertheless gives very reasonable behavior for the sort of interactions we are interested in, which is how molecules make up parts of the cell. What you see here is a lipid molecule that Tom talked about yesterday. So they form these lipid vesicles, these walls of organelles, and we do a lot of work on that. But the technique can also be used for other things. Okay, time to talk about my class experience. You may have seen my title, Bewildered. I am totally bewildered by the class project, because it seems such a long way away to talk about synthetic chemistry and simulation of molecules. How can we bring these worlds together? This was to be a big puzzle. But we got talking, both to Agnes and last week to Sergio and Ottavio, and we found some nice touching points. And I want to report on what Agnes and me did. I have to say that from my perspective, I was acting as a, what's the word? Yeah, I was driven by the artist interest. So it's not that, of course I showed my work, and then I was not waiting for the artist to basically use that But I was saying, okay, what are you interested in, and how can I sort of contribute to that, or with my tools, what can I do? And so Agnes will talk a bit about her tree project, which I won't say anything about yet, but I will first I will introduce now the basis of what my sort of research or how that links. And that has everything to do with self-assembly and self-organization. So I've been at the University of Delft. We are basically have developed this Martini model to model the self-organization of molecules on a surface. And this is important because if you can manipulate structures on the nanoscale, you can again reduce the size of all kinds of components. So it's about nano-patterning. And you cannot deposit any more particles on a surface so easily to give you a particular pattern. So you have to convince the molecules to do it for you. And how do they do that? By recognizing each other. So in this case, we're talking about long-chain molecules that are in part alkane-like, so oil or waxy when they get longer, and in part they're amide-like. And amides are the basis of also polymers that make of nylon. And so alkane parts like each other, but the amide part likes each other more. And so then when you put a droplet of this stuff on a surface, in this case graphite, it starts to deposit on the surface and then starts forming these lamellar organized structures. And this goes over time. It takes a while. Also, you see it's still dynamic. So even though overall it's organized, there's still dynamics in it. And this is actually very important that it remains dynamic. And this is when you want to control things on the molecular scale, this is what you're up against all the time. Everything remains dynamic. So it's very hard to gain really control and freeze things in. So this is basically the link. And now Agnes takes over, and I will rejoin a bit later.
Hello. Yes, it's working. Hello. Okay, first, thank you very much for inviting me. It's not very loud, huh? Like that? For inviting me, and of course I'm very happy to be one of the class award recipients. But I will introduce you to I have two class projects, but before I want to introduce you to my work in general, and then talk about the work I did which leads to my class project ideas. As an artist, I'm working at the experimental edge of art, science, and technology. Oh, I'm too far. Exploring the zone between fact and fiction. And in 2003, I founded a small institute, the Research Raft for Subterranean Graphology. Here you see our first raft, which occurred during the metro construction on a subterranean lake in Cologne. And the main aim of the research raft was at that time to explore and confirm subterranean phenomena, such as microscale universes in stone and earth cores or subterranean icebergs. I developed tools to search, and with the help of these instruments, everybody is able to perform a type of field test exploration into possible hidden worlds. And yeah, since 2007, I'm not only investigating layers of reality very deep down, but also very high up, inside and outside Earth. I'm comparing the parallels between these extremes. And with after 10 years of successful research in 2013, and with the expansion of my interests and research fields, I renamed the institute. It's now called Institute for Art and Subjective Science. And you see there are more than 35 departments in the meantime. They are structured in subterranean, terrestrial, and celestial departments. Inside these departments, you can find all projects behind some long-term projects which develop over several years, or projects which need more development. And yeah, the Institute doesn't produce answers but questions. We search for the unknown. It's a poetic approach to the unknown. And we are probing remote realities, constructions of realities. Realities inside Earth, outside Earth, but also inside smallness, hovering in air or in ice. Here, let's have a look at some departments. The department for the undefinable, here working in an ice cave in the Perito Moreno Glacier, but also outside the glacier, laboratory for dropping studies. The department for strata and its Earth Collaboratory and ELF-SCAN. Here, the Department for Mathematical Magic is focusing on the calculation of meteorite trajectories, and so far we were able to predict 2 meteor falls, and we organized then public meteor watching events. Here 42, the large meteor terrestrial rerouting array pad outside the city of Marrakesh in the desert. A large antenna array to investigate the possibilities of steering meteorites. The Department for Gravitational Anomalies is investigating methods and methods to investigate gravitational anomalies and to visualize them. Here one example with the help of hammer and feather. Another very large and important department of the Institute is the Lunar Migration Bird Facility. The Mongoose Colony, one project of it, is a long-term, still ongoing performance, experiment, film, and installation, where I started to breed my own moon geese on a farm in Italy in 2011 and trained them to become astronauts, to travel to the moon one day. I will show you just one method. Ah, I forgot the sound, to connect the sound to my laptop. But, okay. It's not, now, ears. Yeah, you should. Okay. Okay, another, in 2007, I was working in zero gravity in cooperation with the German Aerospace Agency, and surrounded by scientists and their experiments, I conducted an artistic experiment to study cloud cores, also called aerosols, and their possible inner worlds. I guess all of you know that aerosols form the basic for drop formation, therefore cloud formation. All these different experiments and expeditions find their public manifestations in different formats, installations, public happenings, documentary format, such as, for example, here, the flight laboratory from the airplane now got transformed into a cloud machinery and machine metaphor, here displayed at the Sharing Foundation. And another example, for example, are the findings, cloud cores, findings also from the weightless flight, lately from an exhibition in Basel. Okay, now we go into the woods, the Finnish woods. Here a workshop from the telemetry department. During my preparation for the experiment in weightlessness, I was talking to several cloud scientists, and one, Ulrike Lohmann from Switzerland, she told me that when she was working in Antarctica, and one day she went out with a hot cup of tea, and she was very surprised because the tea didn't steam at all. So the air in Antarctica was so clean, there were not enough particles to form a tiny cloud above the tea. that was, this moment made me I got very interested in microclouds above T. And in 2013, I had the great chance to be artist in residence on a Finnish SMER station for forest ecosystem atmosphere relation. And when actually they measure everything, they investigate everything from the soil, from the trees, clouds, climate, all the relations together, and they measure everything, nearly what you can measure there on site. And when I arrived there, I always had the sentence from this cloud scientist in my head, and the first thing I did, I invited the scientists to have a tea with a tree, and I developed a telemetry station there in the forest. And yeah, of course the tea had to be investigated under different environmental circumstances. I learned a lot about clouds, VOCs, blueberries, trees, and so on. 1 year later, I went back to the research station, and I brought the instrument, teacup tools. There's still not the sound. It's connected, but it's not so. Let's leave it. Okay, the teacups tools you can see here. It's a multifunctional tool to investigate the tiny microcloud above the T and the environment. And the tea actually is made from everything which falls into the cup. The rain, the litter, and we have here our little sensor station attached to the cup, and we collect a lot of data about the tiny cloud, about the environment. And during the calculation and analysis of our huge amount of data, the computer gets hot, and we use this heat to boil the tea, to cook the tea. So it's an endless loop. And depending on what the cup is measuring, it's moving into various heights. So it's an instant aerosol visualizer also. You can also log in with your cell phone and see in real time the cups moving. There's also a message log. It's a quite complex tool and project. And air and aerosol doesn't have borders, and it's also important to measure at different places. So we are working now on the development of the global teacup network, placing teacups all over the world. I show you just a few places. Here on a rooftop in Linz, in the frame, these are also air particle samplers. Also here an indoor measuring station. There again an outdoor measuring station. It is here, that's also an air particle sample station. It's a very traffic intense street in Switzerland, and we place the cups everywhere like parasites. Okay, let's go from the tiny clouds into the larger clouds again. I guess you all know that trees emit VOCs, volatile organic compounds. These contribute to aerosol formation, this also to cloud formation. And VOCs, they are very difficult to measure because they disappear so speedy. And yes, I heard that, for example, when they get too much sunlight, they emit more VOCs. And then, when they emit more VOCs, they produce actually their own cloud. So trees, when they get too much sunlight, they produce their own cloud to produce shadow. So each tree, but also each tree makes its own cloud, but sometimes it's very hard to say which cloud belongs to which tree and tea. Okay, measuring the invisible, so we have millions and billions of tiny invisible particles here in the air, and how to measure all this invisible things. And I encountered wonderful methods there at this research station to measure the gas exchange and taking gas samples. For example, this chamber measurement, they measure what the needles are breathing in and out. Here is a soil chamber. They measure what the soil is breathing in and out. This is a tree trunk chamber, measuring what the trunk breathes in and out. And here I come now to my one idea, is how to become a tree for another tree. It's a biochemical poetic odor communication experiment, so to say, because I'm fascinated by the idea that each tree has a specific typical VOC emission. So it has its own specific VOC cloud and identity. And I'm thinking how to recreate this one tree ID to synthesize a perfume of it. Then I could smother myself with this perfume and then sit next to the tree and maybe, I don't know, maybe when will I become another tree for the tree, or maybe even his twin. I can, of course, then, it would need a kind of instant translation system to measure again the reactions of the tree. And there could also a tiny synbio machine maybe fit in with a microbe sitting here and singing the song of the tree to me, or in reverse. Well, it's a big project, but that's one idea. And now I come to another, the other project, which is focusing on walking trees. And trees and plants always have moved and migrated. They always have adapted to the changing environment. And nowadays they wander up mountains, they go north, you can read. And the project focuses on the situation actually that climate change takes place nowadays so fast, faster than trees can adapt and migrate. And I'm researching possible methods how to support trees to migrate faster, trees and plants, from various perspectives. This is an experimental research arboretum in Berlin. In 2016, I opened up the first office for tree migration on a forest clearance in Denmark. It's a permanent little station. We observed one tree passing very slowly the clearance over several days. The tree control room. And you need long-term recordings. Okay, but now that was the first office for tree migration, and then I thought, okay, I want to go deeper in, but sometimes you have to start really small. And then I went in August to Groningen. And that's a moment where Alex again comes in. And we opened up a temporary office for tree migration in Groningen. And yes, there you see. And how shall we, about the tree molecule? Yeah. And I met Alex and we were thinking about, we can simulate tiny walking tree molecules. Because I'm thinking, okay, you have to start small, but what is, I mean, the large trees, they cannot walk so easily, but what would be the smallest tree, actually? If we start very small, tiny, tiny, tiny tree clones. And how can we make them maybe migrate? How can we make them sense the environment? But of course, you have to start very small with super tiny tree clones, or even smaller with tiny tree molecules. And then we started to synthesize tree molecules and to simulate an experiment with possible migration systems.
I can maybe explain a little bit about the design of this tree. Because as of yet, this is a not existing molecule. But I found it important to make a molecule that could be synthesized. So I could give this to an organic chemist, and the organic chemist could synthesize this, because all the ingredients of which this molecule is built have already been made. So I showed you before this part, which is this amide group, if you remember, and the alkane part. That is used in experimental labs, say in Delft, where we just saw the simulation of how they self-assemble and form structures. So I thought that's a nice start, because that can be on the surface. And then from there on, I would like to have something that resembles a stem, And there I take something from nature, namely alpha helices, which are a nice stem-like shape. So this is a part of an alpha helix, and then on the top, well, we have molecules called dendrimers, and they're actually tree-like structures, and they're used already for drug delivery. The thing there is that it has these groups that can be charged or uncharged depending on pH. And so when they're uncharged, they form, say, a fairly tight cloud, if you like, which will capture small drug-like molecules. If they come in lower pH, these groups will get charged, they repel each other, and they will open up. So these molecules all exist.
Yeah, but maybe these were our first attempts here, our molecular trees, the first ones. Some tests, and shall I show the video?
Yes, well, why not? So here you see a zoom out, which is basically the setup. So the idea of their migration on the long term would be that there would be a hotter region and a colder region. And so we would like them to choose. Actually, the idea was that we want to have them to the colder region. I will maybe say a little bit more whether that worked or not. So that's the general setup. So we have molecules that form the soil that are very much like the roots, but some like the roots more than others. And what you see on the other screen are more zoom-ins and what it looks like when it's actually moving on a short time scale. So this is roughly an order of a picosecond motion. And on picosecond motion, they move a little bit, but they don't really do much.
Yeah, here, side view. Yeah, so there was kind of process to, on the way to create this molecular tree molecules, which then could migrate over this temperature gradient. And
maybe I should show the results of the latest hot result, which I only got last week before I came here. So I've been playing a little bit with the difference in temperature, and at first it didn't really work that well. It still doesn't work quite well, but this is a very strong time-lapse movie. So this, the movie will go over roughly 5 microseconds, and watch the trees. They move like crazy. I said it's very difficult to control motion of molecules. But you see every now and then, these molecules like to come in this ordered part, where it's colder. Where it's colder, it's ordered. Where it's hotter, it's disordered. And my hope was that these molecules that enter here would actually be captured there, because the energy there is lower, but yeah, the entropy is also lower, and so yeah, it's a battle of who wins. So I probably, hopefully, can change the design a bit that they stay there for longer, but at the moment, this is what we've got.
Yeah, and I hopefully think that one day, maybe, there's this, in these tiny fluids, there are some tiny walking tree molecules inside. And then we could grow them on a medium and have a tiny walking tree arboretum. These are little tree clones. So, but it's a long way.
Okay, thank you very much.
Hello? Okay, thank you so much, Agnes and Alex, for the presentation. It was super exciting. Let's, Ingeborg? Oh, it's here, sorry. Thank you.
Thank you very much, Rodrigo, for this wonderful opportunity to present to you a new study program that goes in the field of art and science collaboration and is a little bit broader than that. I really much enjoyed the last 2 days. It was very interesting for me, and I learned a lot what I can bring back to Vienna. At the University of Applied Arts in Vienna, we started a new bachelor study program we call Cross-Disciplinary Strategies, Applied Studies in Art, Science, Philosophy, and Global Challenges. So this is about as broad as we think the horizon could get. There is an art and science a master in Vienna. There is a master degree in trans art, also in social design. So there are a lot of other contexts already at the art school where art and scientists work together. And of course we have also people from chemistry, from biology, in some of the departments, and engineers in the department for architecture. But to show you in a couple of words what we aim for, I will just read a few lines from the flyer we just produced to hire our next generation, because we just started last October. So the curriculum of the eighth semester bachelor degree course, Cross-Disciplinary Strategies, draws on a broad spectrum of knowledge from various disciplines and covers basic principles from the field of art, philosophy, science, engineering, and the humanities, as well as artistic strategies. So there is a possibility for the students to go into the art classes, but the main interest for us is referring to artistic strategies, to work with these strategies in the sciences. There's also emphasis on exploring the foundations of contemporary challenges, like the increasing merge of humans and machines, advancing automatization in the world of labor due to the rise of robotics, the arrival of artificial intelligence in almost all facets of everyday life, and on addressing current perspective on human rights. Human rights issues is also a very important topic in this curriculum. So this integrated curriculum seeks to provide new strategies and develop future-orientated working and learning methods to promote a critical approach and collaborative skills. It presents alternatives to the advancing specialization and fragmentization of knowledge in confrontational forms of teaching, and is thus a contribution to shaping or to shape the future of our societies. Fragile social fabrics in a rapidly changing world that are currently facing unpredicted challenges, what we call global challenges, and dynamics on a global scale, such as democratic change, climate change, mass migration, scarcity of resources, violation of human rights, social inequality and poverty, mass unemployment, the redefinition of human labor, and the participation of all people in the human community in the digital age. So this is a very broad spectrum, I guess as broad as it can get. So, and now I want to show you just for a short brief. We have a couple of experts working with us. So we couldn't do this just, with the stuff of the university, and we were able, especially the president of my institution, Dr. Gerhard Bast, who was constantly, I would say, for the last 15 years working to make this happening, is Manfred Nowak, a very famous Austrian a scientist or researcher in the field of human rights issues, who has for himself also developed master degrees in human rights. Then we have René Schröder. I guess some of you know her perhaps. She worked with Emmanuel Champondier on CRISPR-Cas, for example, and is a specialist on RNA. And we work with Robert Trappel, who is the head of the Austrian Research Institute for Artificial Intelligence. So I'm also teaching, and one of my colleagues is teaching, and we also have Tanja Gesell. She has studied in Düsseldorf Fine Arts, and then she also studied computer sciences and biology, and is a very important bridge for us between, René Schröder and our art students. Then we have a colleague from the University of Vienna who's teaching philosophy. We have Harald Katzmeier, who is teaching our students how to work and how to develop networks. And then we have Christina Pierhofer, who is giving courses on an introduction on the on basics of scientific research. And then we have Christine Böhler, who's also involved in teaching, and David Campbell, who is giving an introduction into scientific writing. So what these bachelor students need is also some core introductions. Then we have a couple of guests, like this semester we have Katharina Xöllpointner. Next semester we have, for example, Thomas Feuerstein, or another artist, Herwig Türk. We also developed new formats of teaching where we have scientists, artists, and people from the humanities working in the same class together. The students really like this kind of co-teaching, so it's not just that they listen to one professor and then go to a couple of hours later to the next professor, but they have a kind of tandem, a co-teaching situation. And our first students, this is our first generation. We just started in October. In January, we start to hire the next generation. We have about 25 students each year. So, and we're also working on a master degree and a PhD program. So it will be quite a significant number of students quite soon. But I will also talk about the context. Where are we situated? The university was able to get a new building for this study program, and we also have, which is quite interesting, Peter Weibel, the Peter Weibel Forschungsinstitut für digitale Medienkultur, which was just founded. Then there is us, and then there is the Department for Digital Art. They have the second and the third floor, and they also have a full dome. And we also have a kindergarten. So from the beginning to the retired Peter Weibel, so we have, the whole house, 3 generations, I guess. So, and we are in, I haven't got a photograph of the building we are. We are in the Hintere Zollamtstraße, but there's also the Vordere Zollamtstraße, where we also give some we'll give some lectures, and it is quite important that architecture also follows the idea to bring, to enhance communication and exchange. So this is the inside. It will be open in April, May, so in a couple of, so about 6 months from now. And there's also a huge library in this building. And and the whole architecture was designed to be as open as probably these classes can get. So my own research is, which I will talk for a minute, is in the field to look from the perspective of the humanities, how art and science is collaborating or working together. So my PhD, I started in the beginning of the 90s. In the middle of the 90s, and then it took a while until I finished it and could publish it. And I also could publish it in English with the help of the Andrea Verbraun Stiftung, which was fantastic because the first book I could then publish with the help of my family, which was also fantastic. And I'm also interested in art and synthetic biology, and it was great to publish also with the Schering Stiftung. And this background is a very good starting point to talk with the scientists, but also with the artists and the people in the humanities, because having such a broad perspective in a bachelor program is a kind of a challenge. And so 2 more publications. Yeah, this was a good pathway also to learn about what, for example, the Schering Stiftung does. And Pina Yoldas, for example, she also exhibited there, and quite soon she will be also one of our teaching staff. So this is what we do in Vienna, and we just started. But I think it is a strong commitment by an institution to educate students that will not be artists, but of course they have a BA, but they have the opportunity to go into the art classes to listen to lectures or to do some hands-on experiences. But these students will not be, or I guess they will not go into the art world, but rather maybe working with NGOs, for example, the Global Challenges Foundation in Stockholm or UNO or wherever they will end up. But what is an important part of our curriculum is to reflect on how the labor market, on how work, on how production lines are changing through artificial intelligence and robotics. So most of the students have a very positive perspective towards their own, I would say, career or life later, because they are quite aware that probably the jobs they will go into do not exist yet, but maybe in 2, 3 or 5 years from now will exist, because the labor market will change so rapidly. So this is about my presentation, and thank you very much.
Okay, thank you so much, Ingeborg. So hello again. The portrait? My presentation? I'm sorry, I was supposed to do this. That's it. Okay, so hello again. Well, I first will explain a bit who I am and what I do, and then I will try to quickly comment on a couple of topics that afterwards I hope we will be able to discuss with the rest of the participants of the panel. So I'm based in Barcelona, and the remote. I can change, okay, I'm going to do it like this. So I'm based in Barcelona, and among other things, I write, I teach, and I also curate mainly in the field of experimental music and so-called sound art. And as some of you might know, this is a very controversial and highly debated term, and I am myself not too proud of it, but of course, this is not the place for such discussion, so I'll just leave it for another time. So let's just say that I am interested in the study of sound and its necessary counterpart, which is, of course, listening. And following this interest, I am currently working on my philosophy PhD with a project that addresses the phenomenology and the post-phenomenology in the context of the work of this guy here. I guess you probably, some of you know him. His name is Alvin Lucier. He's now 86 years old. He's still working, and he's probably one of the most important and influential sound artists alive today. I cannot extend about his work now, so I'll just say that Lucier's work is so much related with science, as most of his pieces deal with the exploration of sound phenomena and different physical elements or events that are at play when something sounds, or when two or more sounds interact with each other, or when a sound activates a given space in a given way. So resonance is definitely one of the main topics, issues in Lucier works. But why am I speaking about sound and why I think sound is an interesting topic in the context of this workshop? Well, to use someone else's wise words, Stephen Connor claims that what we nowadays know as sound studies has not been parsed simply because there is sound or because sound is just there. The study of sound is part of a larger project or program which is aimed not just at explaining what we know about sound, but changing the nature of knowledge about everything and the manner we have of acquiring it. Well, maybe this idea can seem a bit too, let's say, enthusiastic, optimistic, about or confident about what the possibilities of offered by sound, but I still think there's a lot of truth in these words. Sorry. Yeah. So I think that in the context of a strong ocular-centric tradition, and this is a tradition that provides vision over the rest of the senses, sound and listening can contribute to a certain epistemological shift that can be of huge importance also in the field of science. Maybe this has to do with what Will Strimshaw, I'm never sure if I pronounce his name right, but this guy, he says about the notion he says that about the notion of what he names solid materialism. So in a recent and very interesting talk that can be found online, Scrimshaw says that taken from the materialistic perspective, sound is a very appropriate medium to address and or to refashion the real. Whereas the visual regime would seem to suggest a certain kind of transcendence, and meaning that something that goes beyond the visual representation, sound would be in its very own nature closer to a certain form of immanence. Maybe, Scrimshaw says, that is because after all, just like it happens with sound, the real is also very often in flux. But let me go back to Lucier now. One of his best known works is Music for a Solo Performer, and here you see Lucier sitting in the chair next to John Cage, who was the person who encouraged him to get this work done for the first time. To put it very shortly, Music for a Solo Performer consists in the amplification of Lucier's alpha waves through a large set of speakers that are used to put into vibration different instruments distributed around the space. Here's what the installation or the performance set looks like. So the reason why I'm talking about this piece is because I'd like to introduce a term that I'm sure most of you know already, and it's that of sonification, and also to pose the question, which is Alvin Lucier Music for a Solo Performer a good example of sonification? So, if sonification is the transformation of data into sound in a way that allows us to rate and understand that data in a different way, or to put it in Connor's terms, sonification may allow us to change the nature of knowledge we acquire from a certain object or event or phenomena. So among the advantages of sonification, there's the possibility of monitoring things in real time by means of abstract audio signals. A good example of sonification is this is Wanda Diaz Merced. It's a Puerto Rican astronomer that lost her sight after spending many years studying and investigating the emissions of gamma ray produced by supernova explosions. So by means of sonification, she identified some interesting features of these emissions that could be grasped visually. This, I think, is a good example of how sonification can also be used towards creating accessibility, which is one of the words that appear in the title of this panel too. And accessibility, I think, might refer both to the creation of a system that allows persons with a certain disability to access information, but also to explain complex phenomena to general public and or non-scientific groups of people. But what is really interesting about Diaz Merced discovery is that the sounds she obtained by means of sonification of data, when combined with visual representations, can also give extra and very valuable information to perfectly sighted astronomers. So it can be said that in certain situations our ears can maybe identify patterns, meanings in a different way, maybe even quicker, easier, or more naturally than eyes can do. But sonification, as many people has been warning lately, can also be problematic or untruthful when it is continued excessively by a certain bias of the creator of that sonification based on what he or she thinks the phenomenon or the object should be sounding like. Or to put it in another way, the problem might be here an excess of creativity or imagination. So, is Alvarez here piece a great example of sonification? Well, as much as I love Lucier's work, for many different reasons, I think it cannot be taken as a good example of sonification. And actually, I'm sure the piece doesn't intend to work in a sonification level, but more in a theatrical or performative way, as the title "Music for a Solo Performer" indicates. So what I would like to suggest, in order to start the conversation with the rest of the participants, and after Sergio plays us a bit of sounds, what I would like to suggest is the question of whether or not sonification encapsulates some of the most basic problems and dangers of these art-science encounters we have been addressing here for today, the second day. So to what degree are scientists and artists supposed to be creative or imaginative when working together? Are there certain rules or red lines that have to be considered? And how should they put their respective notions of creativity and their imagination together? At the same time, of course, the notion of fiction or poetry, and to use two words that Agnes has used in some occasions to describe her own work, are key elements that necessarily have to be there to create a fruitful interaction between scientists and artists. I guess this is also related with another term I find interesting, especially after hearing Agnes and Alex's presentation, which is that of speculation. And so maybe we can also talk a bit about this term. And last but not least, what is the role of technology in all this? And Bruno Latour suggests in his article, Morality and Technology, that technological artifacts are not neutral objects or tools, but a mode of the relationship with reality that Latour suggests does not simply intermediate, but actively mediate So in this sense, I think that the tools originated by these technologies might be enriching when shared between artists and scientists. So maybe the tools can be the beginning of a fruitful interaction and shared knowledge. And why not start by sharing the experience of how certain technological tools or apparatuses or procedures used both by artists and scientists have been influencing certain processes in the either in the science lab or in the studio. Yeah, I'm sorry that was a little bit too long. Please welcome Sergio.
Good afternoon. It's a great pleasure to be part of this presentation, and I'm going to talk a little. It's a great pleasure. Definitely, it's a great pleasure. Definitely, it's a great pleasure. Definitely, could I transfer? Could I definitely, it's a great pleasure to be part. Definitely, it's a
Good afternoon. It's a great pleasure to be part of this presentation, and that's it. Yesterday I heard me making some sense, and I was wondering throughout the day yesterday and now today that the thing that I might be missing would be not to make sense. So that was kind of the goal. Take some breath for that. And this thing that you saw, I built yesterday or today because I didn't know I was supposed to talk, and I thought not talking would be the best way to present what I wanted to present. All this technology that I work with is part of the partnership that I have with Otávio, and which is being applied in this class residency. And I'm super happy because right before coming here, I was kind of stressed out because of setting up. It's kind of sometimes doesn't work. And but then Aaron invited us to his lab, and then he came to me and he said, we really want to try to sonify some other stuff. And I was really super happy to know that the work that I've been developing with Otávio and with Alex in Groningen of making RNA molecules into sound was interesting for another research, and the fact that we can connect that research with Groningen University to here, to Max Planck, is really a great news for us. That's it.
So the next presentation will be by Professor Fratzel. He's the director of, one of the directors of the Max Planck for Colloids and Interfaces, And he's also heavily involved in the interdisciplinary cluster, who is doing amazing things that he hopefully tell us about.
Well, thank you. So I was asked to make a few comments about interdisciplinarity. I think I'll start with something provocative. The whole concept of interdisciplinarity is really an academic brainchild. I mean, go out to industry, you will see engineers work with people with an economic background, working with marketing people, and they would not say that they're interdisciplinary. So what is the main difference? The main point is that they have a common goal. As soon as you have a common goal, you can join forces and work for that common goal. In an academic context where we work on curiosity-driven research, this common goal is defined by the researcher, him or herself. And then interdisciplinarity becomes a topic, really. Now, I think probably when scientists and artists work together, as we've just heard and saw, probably the common goal that they have helps a lot. I'll actually be interested how they do it in the Angewandte with these classes, yeah? If there is a common goal defined in the beginning. Now, you've heard that I'm here in a department of biomaterials, and I always thought that having chemistry, physics, biology under the same roof, everybody working together, was already something. But for a few years now, I have been involved in, as was already mentioned, in a cluster, in one of these excellence clusters in Berlin, Image, Knowledge, Gestaltung, Bildwissen, Gestaltung, where it turns out that working between science and humanities is really, again, a very different challenge because of these differences in culture. Now, let me just mention that in this English title, Image, Knowledge, Gestaltung, Gestaltung was not translated, of course. This is on purpose, because we wanted to have many aspects of Gestaltung, from art to design, from industrial to design to art, really, to be part of all this. Now, I'm not going to read this. I'll just go quickly through a few slides and make a few comments. I'll not be very long. So it's a big enterprise, 350 researchers, 40 disciplines, 50 partners, 30 research projects. I don't read all these disciplines that are assembled. They do not collaborate everybody with everybody, fortunately. Otherwise, we will have to make an exponential calculation on how many people, how many projects we have. But here is some matrix of projects. Active matter, I just participated before coming here in giving a talk in a video conference through video to a conference in New York about active matter. That's why I came late today. And so there, one of the ideas that we're pursuing in a variety of discussions is really to look at matter, even if it's not containing cells. I know that we are talking about synthetic biology here, among other things, but just imagine that even without cells, you can have adaptive matter, you can have polymers that change color depending on a stimulus and so on. You can even have materials that move depending on air humidity and so on and so on. And just to show you, these are some of the projects that are pursued in the biomaterials department of moving objects, and they all move not because they have cells driving them, but because they are absorbing humidity from the air. These are just polymers, nothing else. And still they move, and still they are active. And this is a pretty interesting concept in talking about matter in this specific way. And of course, folding is one aspect that transforms matter into something more refined that brings a two-dimensional into a higher dimensional structure, for example. And here you see some of the books and conferences that this cluster is working on. This was the big cluster exhibition in the Gropiusbau end of last year. So this is what's going on there. And well, it's a little bit like what you're trying to do here in 2 days is something that is a typical setting there in this cluster. Now let me make a few more comments about how to go about this and interdisciplinarity, and in particular this interaction between Gestaltung, humanities, and science. In talking to quite a few people, for example in art schools, especially in applied art schools, it turns out that the distance between art or Gestaltung in general and humanities may even be greater than between art and science. The reason is, again, a little bit linked to what I said before. If you focus on an object, and you can focus on an object in art, whatever that object is, you can focus on an object in science, but you don't have this. But if you have a historical perspective, it's a very, very different attitude, and collaboration, I think, is possible, but more difficult. And I don't know if this is an observation that you can make. There is, in the university already, hardly any interaction between humanities and science, but then Gestaltung actually are in different universities. Why is there no Gestaltung in our typical universities? Why are there art schools that are in different buildings in different parts of the city than the rest of the universities? This is a question you can ask, and certainly it's a question we are asking, except for architecture, that the engineers consider, at least in part, also an engineering discipline. So I think one of the goals one can have, and certainly one of the goals we have started to have in this Gestaltung, in this image knowledge Gestaltung, and which we are trying to now push into the next stage of the Exzellenzstrategie by a new cluster that we are proposing, is actually to overcome this divide, if possible. So, well, I'm just mentioning there is also a master program, Open Design, where there is a collaboration between, again, science, design, and humanities. And this is a little bit the vision. So let me just give you a very simple-minded picture of a natural scientist. So a natural scientist may, especially interested in materials, may be looking at the structure of things out there, like your own body parts or trees. We've heard about trees, and then, of course, this is what you see. This is the structure, the object, and of course, this has a function. And again, I'm taking function in the most general terms. Can be aesthetic or technical or biological, whatever you like. And of course, we try to understand the relation between structure and function. But when you look at the natural object, what you see is the structure. But what the organism does not tell you is what the function is. What is the reason why this structure appeared? And this is what you try to elucidate. And I think just think about what design is. Design is the creation of structure for a specific function. And it's drawn that way, but what I mean is there's more symmetry than one would think in the beginning about these two approaches. Somebody earlier mentioned something about creativity. I think I would add to creativity analysis. Yeah. So I mean, the artists may define themselves through creativity, but why not also through analysis? And I think many of the examples we heard here was how can you use maybe science or technology to improve artistic creation. I might also ask, how can we use artistic creativity to improve scientific research? I mean, just turn this around. And well, I don't know yet how to do this, but I think also with the help of humanities, we may be inspired a little bit by the new Bauhaus, by the Hochschule für Gestaltung Ulm, by the Black Mountain College, by these kind of institutions where people were working really together. Not in a linear fashion. First you have science, then you go through design to industrial production or to art or so, but having it both ways, one direction and the other. At least this is the dream that we can have, and certainly something that I would like to pursue with my colleagues, many colleagues in Humboldt University. Now my last comment is really also directed to the universities. One problem we are noticing is there's no way for designers to do a PhD in Berlin. Yeah, very interesting. So you can do well, if you're a designer, you can make a historical thesis, but then you're in cultural history and not in design with a practical work. Although you can do a PhD in experimental physics. So just think about, you're doing a PhD in experimental physics, where the thesis reports the invention and the creation of a scientific instrument. Then I ask myself, why is it not possible to have a PhD where the thesis reports the invention and the creation of a work of art or something else? Yeah. So these practical theses do not exist at all. Yeah. You can. So this is certainly a discussion that may be quite interesting in the future. There are different views on this, but certainly something we are trying to address, at least in one of the institutions there in Berlin, the Hermann von Helmholtz Institut für Kulturtechnik, where I'm also a bit involved. So thank you for listening to all this. And Wolfgang Schäffner, who is one of the partners, he's just on the other side of the ocean today, so what can I say? Thank you very much.
So now I will like to give the word to Sabine Adler, that is the coordinator of the Eres Stiftung, and René. Sabine, do you mind if I sit up before you, because you need to leave at 7? Okay. It's 10 minutes. 10 minutes. 15 minutes.
Yeah, good evening, ladies and gentlemen. I feel very honored to be able to speak at this occasion, and I want to thank you for the kind invitation, especially to Rodrigo. Many thanks. I got a lot of very interesting inputs yet. My name is Sabine Adler, and I'm a director and curator of the Eres Foundation in Munich, a foundation that is devoted to fostering the dialogue between the arts and the sciences, focusing on questions that are a primary concern to society. So we talked a lot of art and science, so I just jump in a work of art. What you can see here is a work of art by a German artist, Stefan Huber. Title of this artwork is Map about the possible approach of the complementary territories of the arts and sciences. This was shown in an exhibition about mapping and geographics, about digital GPS systems and old school printed maps. What you can see on this map is on the right-hand side, there is the sphere of science represented by the motif of brains. All these brains have names of famous scientists like Charles Darwin, Robert Koch, or Werner Heisenberg. And on the left-hand side, the arts, you can see the arts, represented by the motif of the eyes and the heart. And these hearts and eyes and brains are taken by anatomy atlases. So where both words meet, there are certain interfaces. You can see in the middle little islands, and it's very small to see, but I can tell you what the islands are called. They are called deduction, intuition, experiment, talent, abstract thinking, and monitoring. Only a few of these are mentioned now, but these islands in the map of the artist, they have different sizes. Deduction, for example, is very big in science and it's tiny in the arts. Fantasy is very big in the arts and very tiny in science. And as the artist sees it, trial and error is very big in the science and very little in art. Yeah, and what happens when both worlds merge? Then they are building so-called Verknüpfungsinseln, connection islands. So they have a lot in common. And what will you can see these connection islands in the knitting hands in the middle. Yeah, and what is the artist thinking about these connections? He's thinking about a new continent, a land of uncertainty. He calls it a terra futura main cognita. This is like the Antarctic at the bottom of the map, and there will come out some special things that will emerge when art and science come together, and it can be heaven and it can be hell, we don't know, but we have to decide as society in which direction we go. Now I would like to show you the aim of the ARIS Foundation. We want to advance the public discourse between the arts and the sciences. Its event and publications are intended as platforms to encourage the current discourse between the arts and sciences and keep the process lively and stimulating. And here you have a very funny and highly sophisticated example how an artist works together with a scientist. On the left side you see a very famous neuroscientist. It's Giacomo Rizzolatti. He's the discoverer of the mirror neurons. And on the other side, you have a very famous artist from Belgium. This is Jan Fabre. And Jan Fabre did this video with Rizzolatti. And Rizzolatti made some experiments with monkeys to find out about mirror neurons, about empathy. And so Jan Fabre asked him to do the same experiment between the artist and the scientist. And in the video, you can see a long dialogue between both of them, and so you can see the view of an artist, what he thinks about empathy, about feelings in art, and then you can hear what a scientist thinks about it. And it's a very funny video, and in the end they are also climbing in the auditorium and doing like monkeys, and here they just interact like the monkeys in the experiment that Rizzolatti did before he found out about the mirror neurons. Yeah, we foster, as I told before, the dialogue between the art and the sciences. We do this primarily by the following activities. Since our first project in 2006, we are organizing exhibitions that deal with interaction between science and art. We invite high-level scientists to give lectures in the middle of the exhibition. You can see that here. Yeah, and that is that these lectures take place in the middle of the exhibition room is very special and very important for our concept. There is a symposium. All symposiums are open to the public by free entrance, and often there are also talks between artists and scientists, and sometimes scientists meet in our space other scientists who know each other only by nature articles or science articles, but not face to face. Yeah, we organize also artist talks with the public. Here you see a Dutch artist, Tom Matton. He made a performance when we had an exhibition about the problematics of plastic material. Or here we have another Dutch artist, Tom Verbruggen. He made a music performance and used only instruments from plastics, like plastic bottles or plastic ducks from the bus tube. Yeah, and as I said before, we have a lot of lectures and high-level lectures and panels, and I would like to give you some examples. Here you see a colleague from Potsdam. It's Professor Wolfgang Lucht, the co-chair of Potsdam Institute for Climate Impact Research. Here you see him in dialogue with Professor Detlef Weigel, Max Planck Institute for Development Biology in Tübingen. Here you see Professor Dr. Michael Braungart, Professor for Cradle to Cradle, Eco-Effectiveness at several universities. Professor Dr. Klaus Müllen was our guest, Professor from the Max Planck Institute for Polymer Research and Synthetic Chemistry. We had a lecture with Professor Dr. Thomas Metzinger, Johannes Gutenberg University of Mainz, Director of Theoretical Philosophy Group and Director of Neuroethics Section. Here you see him in an artist talk with the Austrian artist Peter Kogler. We had also Professor Gerhard Roth as a guest from the Brain Research Institute, University of Bremen. Yeah, and here we see Professor Marie-Elisabeth Femonville. She's specialized in hypnosis, and she's the director of the Center for Chronic Pain in University of Liège. Sometimes we also invite people who come not from the sciences, but from other fields. Like here you see Reinhold Messner, very famous mountain climber, and he was invited in this project about geography, and he talked what role plays a map in extreme mountain climbing, and he told us not so much, because intuition is all, and this was very important because here you see the artist of the map. This is Stefan Huber, and he is someone who really believes that intuition is very important for the arts. Yeah, we did a lot of projects about climate change. In 2008, we had something about evolution and extinction of species in the Anthropocene. You see artwork by Mark Dion, an American artist. Here you see Klaus Fritze. He's a biologist and also an artist, and he built his own laboratory in our exhibition space. We did a project about the reality of the oceans, because the oceans are far from dreamlike. You all know about acidification, rising water temperatures, overfishing, and pollution. They are major stress factors for threatened marine ecosystems. Yeah, and we were very pleased that internationally acclaimed filmmaker, photographer, and installation artist Agnes Varda came to Munich to present her work in person. She took part in a panel discussion chaired by Chris Derkorn, the former director of the Tate Modern London, and now, as all of you know, he's at Volksbühne Berlin. And we did this project also together with the excellent cluster of oceans in Kiel with Professor Fisbeck, and it was a really extremely interesting project. Last year I curated the project The Self, an Ego Machine. The central question was what consciousness actually is, and why do we human beings have it. Here you see an artwork by Austrian artist Peter Kogler. Peter Kogler, with a cube especially conceived for this exhibition, questioned the traditional experience of space, and in doing so unleashed perplexing consciousness phenomena. You see another inside of the exhibition. This is with Matt Mullican and Peter Kogler in the back. Yeah, and we also invited a Berlin-based artist, Thomas Sipp. And Thomas Sipp has devised an ensemble consisting of paintings on canvas and electronic musical instruments that function as a neural network with antennas as organs of perception. His music machine turns out to have life of sounds of its own, and perhaps the machine, as he told, has even consciousness. I would like to give you a short insight what we did in topics. So we had something about megacities and art and climate studies. We did a project about plastic, the fascination with and horror of plastics in art and sciences. This is an artwork by Pavel Altam, a Polish author. And then I'm very happy to show you Thomas Feuerstein, because Ingeborg Reichle already told about him, and Heike Mertens. She's a co-partner of this project. You could see this exhibition in Berlin, and now it will come to Munich, and we will open it in the beginning of January. And probably this is the best way to illustrate our work at this example. Thomas Feuerstein is an Austrian artist who works at the interface of applied and theoretical science. His projects interlace insights from the fields of philosophy, art history, and literature with biotechnology, economical and political aspects. And from this amalgamation of topics, he creates an artistic narrative that asks questions about fundamental existential parameters and origins of life itself. Yeah, and in Thomas Feuerstein's work, chemolithoautotrophic bacteria successively break the sculpture down into plaster. These bacteria simultan, I can only say this in German, sorry, supply nutrients to create a culture of human liver cells. You see it here in this bioreactor, as they can form biomass from inorganic mineral compounds. Yeah, and the interesting thing is that he did this project together with Thomas Seppi, Department of Radiotherapy and Radio-Oncology from the Medical University in Innsbruck, but we had already great examples today of the collaboration of both artists and scientists, and therefore I thank you very much for your attention and hope we have a great evening. Thank you very much.
The next speaker needs to leave kind of urgently, so we will shift and Tepervien from the department of the Volkswagen Stiftung in charge of like lectures, I think, if I'm not mistaken. I think it's better if you talk.
Yeah. Thank you very much for inviting me to participate in this interesting workshop. I'm really sorry that I missed the first day and will have to leave straight away, but I'm glad to be here now and talk about the Volkswagen Foundation's so far quite limited experience with encouraging the cooperation between artists and scientists. As you might know, the Volkswagen Foundation is Germany's largest private research funding foundation. Its purpose, according to its statutes, is to promote the advancement of the sciences, including the humanities and social sciences, and technology in research and higher education. So the foundation mainly funds research fellowships and projects, academic symposia and summer schools, with a focus on interdisciplinary high-risk research. The foundation's connection to art was for a very long time limited to sometimes buying art. It was only in 2014 that we launched a call for participation in a 5-day workshop, which was supposed to bring artists and scientists. With scientists, I mean, I use it in the German way. I mean, scientists also means people from the humanities, yeah. In a very small village near Hanover, to start working together. This event was aimed at Europe-based scholars and scientists who obtained their doctorate in any discipline, so it was open to all disciplines. We got very few applications from natural scientists, many from social scientists, and it was also aimed at artists of all disciplines with equivalent practical experience. In the call entitled Arts and Science in Motion, we asked, how is new knowledge gained? How are explanations of observable phenomena generated? What are the processes that steer and shape our lives? restated in this call, answers to questions like these are sought not only by scientists but also by artists, each in their own way. Using the methods characteristic to their respective areas of expertise, they are always in search of and discovering new interpretive approaches. This exploratory worldview creates a bridge between the realms of arts and science. All too often, a rigid boundary is drawn between scientific knowledge and artistic perception. Bringing the two in contact with each other and promoting fruitful exchange harbors great potential. So we received 90 applications from scientists, scholars, and artists, and 29 of those were sort of selected by an interdisciplinary panel of artists and scientists to participate in the workshop. The center of focus at the workshop was motion in a dual sense. Sort of processes of generating perception were to be brought into motion by questioning and probing the borders between science and the arts. At the same time, the topic of motion was at the center of the exchange. The focus was not on gaining presentable results by this cooperation, but on encounters between individuals and their ideas with a view of becoming acquainted with each other's approaches and methods. Unfortunately, I did not participate in this workshop, but apparently it was a very interesting experience for all involved. The participants were offered the opportunity to apply for projects, for 2 years projects in the end, focusing on the topic of motion and particularly on the cooperation between artists and scientists. And they received travel grants in order to be able to prepare for these proposals. In 2015, we received 12 proposals for those cooperative projects, and 6 of those were selected by an interdisciplinary jury. Only 2.5 weeks ago, all those projects met very near Potsdam. Again, seems to be a good spot for meeting artists and scientists. And the projects presented basically their results, they did not present results as such. They basically focused on their exchanging their experience with cooperating. I think every project that presented talked about the difficulties of finding a common language and practice. So some projects had just 2 participants, a dancer and anthropologist in one case. Some were large projects, and they all said that they underestimated how long it would take to actually find this common language and find sort of working practices. And one participant said, we are used to presenting our work to each other, but we are not used to actually working together. Irit Rogov, a professor of visual cultures at Goldsmiths University London, who gave a keynote speech on how art researchers at this event, described her impressions of the meetings as follows. The work I was introduced to at the workshop was interesting in many ways, but I think what impressed me most was the many inventive and interesting ways that the participants found to collaborate. If you think of how many different forms of knowledge come together in such a project, then it makes perfect sense that it would require time and experimentation to learn how to talk to one another, how to make use of each other's contribution. I was impressed by the participants' seriousness and their great desire to challenge each other and the traditions they bring with them. In the booklet for this workshop, the organizers asked, what is the benefit of art-science collaboration? Is it about the outcome, the process? Can we frame or justify its utility or usefulness? My impression at the workshop I just mentioned was that the process itself is extremely valuable, sparks creativity, and generates new modes of collaboration and knowledge production. It is too early to say how the Volkswagen Foundation as a science funder will proceed in this field, though my guess would be that our focus will continue to be not on artistic research, but more generally on new forms of research, such as can generate from the creative collaboration between artists and scientists. Thank you very much.
Thank you. The next speaker will be Christoph von Braun from the Andrea von Braun Stiftung. And yeah, he's the coordinator of, and yeah, also one of the co-founders of the foundation.
Working, yes. Thank you for inviting me here, and I feel a little out of place because I have the feeling that you've been talking about a lot of things that I will only start to mention now. So if whatever I say appears as a triviality to you, please forgive. I would like two things. One talk about the foundation itself, and the other thing is our experience and involvement with interdisciplinarity and with, in particular, the arts and the sciences. The foundation of this foundation was essentially an accident. 3 members in my family inherited some money. And since they all had jobs, they said, we don't need this money, let's put this up. Put it in a foundation. And the big argument that then ensued, and you, Christoph, that's me, you will manage it. I thought, well, why don't you just give me the money and I'll do something nice with it? But they said, no, foundation. So I said, okay, if it's going to be a foundation, it's got to have some purpose. That's always the crucial thing, because when you start a charitable organization, you are essentially taking away tax income from the government. And so the government will always be very wary because it can then buy fewer weapons or stuff like that. What you're going to do with this money, and so you need to establish some sort of purpose for the foundation. Now these 3 heirs, one of them is or was an astronomer, one is active in the field of what you call a computer visualization, and the third works with NGOs in the interest of third world countries and peoples. And each one of the 3 said, of course, well, it's going to be my job that gets supported this. You know, the astronomer said, for the natural sciences, and the computer active said, for computer arts, and the third one said, let's do something for the people in Africa. And I said, this is not going to work, because we can't do 3 things at the same time. And so one of them came up with the idea, well, why don't we not do our fields, but support the interaction of these fields? And then another one said, well, if we're going to do that, sounds like a good idea, but why just these 3 fields? Why not all fields? That's how it came about. So it was founded in 2001. It took some time to convince the government that this was a good idea. They said, what field are you going to support? And I said, no field really, but the areas between fields. Took some time to convince them, but generally they are helpful. So those are the aims, and we quickly specified that the aims would not just be the dismantling of barriers between disciplines, any disciplines, but we would only support projects that involved what we call a broad interdisciplinarity, meaning only fields that have essentially no connection with one another, either in the present or in the past, which automatically meant that combinations such as physics and chemistry were out, because these are old buddies, they have similar methods, similar success factors, similar traditions, etc. So we would not support those. But we would support areas like, well, we had projects, for instance, chemistry and ballet, or Tibetan philosophy and quantum physics, or paleobiology and ship drives. It's all very exotic, you might say, but we are ourselves surprised about the outcome of these projects. There's an enormous amount of fantasy dwelling among people in the universities, also outside the universities, about what we can do, especially young people. I'll come back to that in a minute. also we do not only include academics, but also handymen, craftspeople, housewives, mothers in particular. They have a lot to say. To quote one example, I'll give you two examples. One I will leave out because it's about atomic sonification, and we've heard about that a bit. But I can tell you about this project. It was called Homecoming in Caves. And this was established by some paleo historians, so pre-civilization archaeologists. And they were visiting some caves in the Pyrenees, where you know there are a lot of cave drawings and paintings, Neanderthal age, roughly. And they had found in one of the caves a number of tracks, human tracks, which were fresh mud when the inhabitants of these caves at the time walked through, but which had hardened and which they had found 100,000 years later to be unchanged, only slightly eroded. And they tried to interpret these tracks. One idea was that this might have been a ritual place where there were dances or songs or something. But they had a hard time interpreting these. And then we invited 3 members of the, I think they're called the San tribe or the Nan tribe in Namibia, Bushmen who cannot read or write. They are professional track readers. And they came into this cave. We flew them in, very excited for them because they'd never flown, of course, or even just sat in a car, hardly. And they looked at these tracks, they squatted over them for a couple of hours, talked to each other in this strange clicking language. And then one of them said, you know, this track, she's 16, she's pregnant. And another one pointed out another track, and he said, this guy is 42, and he's got a hunchback, a crooked shoulder. They could see this from tracks that are 100,000 years old. I have to confess, I was pretty impressed. One thing we do is we ask everybody who gets support from us to write a learning paper afterwards about their specific interdisciplinary experience. You know, what worked, what did not work, what went wrong, how did you fix it? If you didn't fix it, why didn't you fix it? Why did it go wrong? And so we publish these papers, and over time we try to establish a certain record of experience working in interdisciplinary groups. Let me give you one more nice example. Kekule's dream. Remember who Kekule was? Anybody? The benzol, right? The benzol structure. Kekule was a chemist in the 19th century. He worked at the University of Bonn, and he was working on the structure of the benzol molecule. The benzol molecule contains 6 carbon atoms, and there's a lot of other stuff around, you know, the side strings, the hydrogen, etc. And he just knew there were 6 carbon atoms, but he didn't know how they were arranged. And while he was pondering this issue, he sat in his living room, and it was winter, and he lit a fire, and he saw the sparks in the fireplace dancing around, and he had a dream. And in this dream, these carbon atoms danced and suddenly arranged themselves into a, what is it called, a hexagon? Area with 6 sides, a hexagon. And that's the structure of the benzol molecule. He found the truth in a dream. And the idea was that it came up to us from a chemistry professor from Darmstadt and a choreographer from Düsseldorf, said we would like to stage this dream as a ballet. And so we organized some ballet dancers, and we had some music, and we had some nice stage props. And this ballet traveled through the Federal Republic. had about 20 showings or so, and I was present at one of the performances in Munich, and I was sitting there, and behind me were 3 high school students. And they had just finished their high school. They were thinking about what were we going to study at the university. And they were sort of hanging in there. I think they were probably smoking a joint or something. And then one of them said to his pals, "Why don't we study chemistry?" And I thought, bingo, that's exactly the idea, that you get the idea to study chemistry while you're sitting in a ballet. So what have we learned from all this? We do about 20, 25 projects a year. One is there's a huge interest and a lot of things going on in the field of interdisciplinarity in this country, which amazed me because you always think the Germans, yeah, they're good engineers, maybe the best engineers in the world, but they're not really the guys who bring up fantastic new ideas. So the PC was not invented here. But we improve the PC, or we improve the cars that others make. In fact, there's a lot of a huge undercurrent there of people who want to do this. So business is booming if you take a university that has maybe 100 disciplines in which you can get a grade. That means you have 4,950 possible combinations. As a trial run, we took the course offerings of the University of Munich and said, how often does the word interdisciplinary appear in the description of the course? There were about 200, but 80% of them were in the area of pharmacology and medicine, which is really not interdisciplinary, is it? And the rest was sort of just a mask. So there's lots of opportunities out there. I also want to emphasize working on an interdisciplinary basis can be risky. You can lose your reputation, you can get all sorts of problems with your colleagues, with people in the other field saying, what are you doing here? You're poaching, you're a dilettante in an area that you know nothing about. And the people in your home field will say, you'll run out of ideas, you have to go over there to these guys who are not really scientists anyway. So there's a lot of infighting within the universities and between fields that makes it risky. You can really put a stake into the heart of what you want to do. One thing that we have learned in all projects is a crucial dimension is language. We expect all our applicants to express themselves in language that can be understood by any newspaper reader. Schopenhauer once said, use common words to say uncommon things. That's the rule. If you submit an application that is full of scientific lingo, and I'm not a natural scientist, and so I can't understand it, I'm going to send it back and say, sorry, I don't understand it. So express yourself in such a way that anybody can understand it. Now, who does this? Well, we found 2 groups. One group, one is differentiated by age. We find that especially young people, the rookies in the science area, are fascinated by this idea. They don't care about the risk. They said, I want to know this, and I will do it. And career, go to hell. I don't care. I want to do this. Which incidentally is maybe an interesting opposition to the fantastic term eureka. I don't think science works that way. I think science works because somebody says, hey, that's funny. What's going on there? And they start a research project, they say, I want to know this. And the other age group are elder scientists. You know, once you have a Nobel Prize, you more or less have the freedom to do anything you want. And a couple of other prizes too. So you can go and fiddle around with what you want. But if you're mid-career and you have, you know, finally, you've got a small team working for you. You have some responsibility. Some money is coming in. Lo and behold, you can afford a holiday. It's very risky then to do something interdisciplinary. So we don't get a lot of applicants for it. And then one thing that really surprised me is this is a thing for women. We have, I think, about 60% of all applications over a long time period now are from women. And when you look at the sexual applications, they go up to about 80%. If you're smart, you would explain this to me. I don't know why. Yesterday, I heard a talk by a female scientist from Munich, a Dutch young woman, and she works on women in research. And she said, you know, it's really funny. You have this pipeline. And whatever share of gender you put into the beginning of the pipeline, at the end, there's always 90% male professors. You wonder what would happen if you only put women in it. In any case, and I have something here that directly counteracts her statement. I say, why is this? And I'd like to know, and if you have any ideas about this, get in touch with me. A few thoughts on interdisciplinarity in general. What is a discipline? Well, there are historic terms. So there are some pretty useful definitions. Most of them are based on indicators like methods, types of literature you have, types of problems you work on, etc. Disciplines are not terribly old. They arose only after Descartes, Leibniz, Newton. Up till then, you had one discipline, and that was philosophy. And then these natural scientists showed up, and you called them natural philosophers. And then only gradually you expanded into other fields. New disciplines arise for various reasons. We've tried to follow that. One, of course, is there are new questions, new realizations, new knowledge that leads to the establishment of new disciplines. There are new discoveries, or there can also be new sub-disciplines, like you have biology, and at some point you develop something like microbiology, which doesn't touch biology itself. Or you have combinations. You have biology and you have chemistry, and one day you have biochemistry. And these become then disciplines in their own right. What you can observe is disciplines multiply like rabbits. They get more and more, and but they live in smaller and smaller hutches, and the walls around them are getting higher and higher, and that's too bad. There is a gradual counter movement. We can definitely observe a closing of ranks among the large fields of natural sciences, economics, social sciences, politics, even culture and the arts. Nevertheless, disciplinary structures are everywhere, and they are relentless in education, in bureaucracy, the economy, everywhere. They start in primary school and they end, well, they don't. Think about it. The last opportunity you have in your education to do something interdisciplinary probably ends in your second year. That's up to this time you have one teacher. And after that you get specialized teachers, at least in Bavaria it's that way. I imagine in other countries it's similar. And then you go on, you have specialized teachers for each individual field. You go to university. Ministries are structured that way. If you write a book, the publisher will ask you, what shelf in the bookstore is this book going to go? Is it self-help? Is it management? Is it gardening? Is it travel? Whatever. You have to tell them where the book will be sold, under what heading. But our brains are not structured along disciplines. It's one big pot in which all the bits and bytes that you have accumulated or that you're trying to put into it can interact if need be. Sometimes, as I notice in my age, you have a hard time finding those bits and bytes again in your memory, but they're there somewhere. So as far as I know, the brain is supposed to make use of everything that's in there, if we can get to it. And trying to organize everything along departments is the best way to suffocate creativity. Little children, untouched by education, are by nature extremely interdisciplinary and can think laterally. Let me give you an example. 2 weeks ago, I visited my son who works in Los Angeles with his family. And because we had time, we were in a hotel at the beach, California, well, not bad. sun was fine, it was a bit cold. And somehow, there were other kids there, somehow I found myself talking to a 4 or 5-year-old boy. Maybe he mistook me for a kid with wrinkles. But he asked me how old I was, and I told him, 71. Then he looked at me quizzically and he said, "Did you start at 1? That's brilliant." Who of you would have approached a problem that's incomprehensible in that manner? You know, it's been educated out of you. Unfortunately, we do this with our children, too bad. Asking counterintuitive questions is something that's very valuable. Not only our brains, our problems, i.e. the issues we use the brains on, are also interdisciplinary. In my conviction, there's not a single significant problem in our society that can be solved with the help of one single discipline. Think about it. Unemployment, migration, climate change. You cannot solve climate change just with the help of meteorologists. You need social scientists, you need economists, you even need banks for this kind of stuff. You need the engineers. Lots of people have to get involved. Our greatest problem, I think, is in spite of all the money we spend on gaining information and knowledge and finally wisdom, we know so little. Of course, we're not completely empty in the head. In fact, I would say we know a lot in the sciences. But hands up, who knows the difference between a fruit and a vegetable? Was anybody? You can try that in a party you go to. It will lead to a lengthy discussion. I won't tell you, only privately. Or what is 30% of 3? Can somebody say right like that? Never mind. We have, in other words, a massive understanding of how the universe works, or how quantum particles behave, or the brain, or heredity, or genetics, or energy, or communication, and the like. Naturally, there's still a lot we don't know, and there will be surprises. But for everyday purposes, we do pretty well, you know, as far as you, as a human go in your everyday surroundings. We even have a notion that the climate is going to the dogs, when that's really a complex issue. But we have not a clue about non-technical systems. In spite of great efforts, we simply don't know how an economy works, or a city, or let's be honest, we don't even know how a marriage works. And that's just 2 people. My wife, we have huge fights, we love each other dearly. She's a riddle. I don't understand this person. And it gets worse. In hindsight, we usually can explain what happened. But with respect to the future, we're reduced to speculation. Even as a very smart person like Mario Draghi, president of the European Central Bank, is actively speculating when he's pondering whether to raise interest rates or not. He thinks he's following certain rules of the economy, but the economy sometimes just stubbornly refuses to follow those rules. We don't know how things work. So interdisciplinarity is more than reorganizing school subject or an occasional exposure to other fields. I think it can and should be much more. I think it's also about taking responsibility, and is here where I can see several roles for the artist. I'll give you some thoughts on that. If I have the time? No. Ask the audience.
Or maybe, I don't know.
Okay, I'll give you a very few examples. One was an artist. We supported Ludovico Cigoli and conflicting truth claims around 1600s. Cigoli was a Renaissance painter in Florence, a friend of Galileo and other scientists of the time. Beyond art, he was also interested in astronomy, anatomy. Remember, it was forbidden to take dead people apart at the time. Or in literature, hydrostatics, and music. He participated in what was then cutting-edge research. In these devotional paintings, however, there are many are in many respects paradigmatic of the confessional era. There is a famous painting by him in which he depicts the ascension of the Virgin Mary into the heavens, in which she is standing on a sphere, which is quite obviously the moon. The moon, in that image, shows the moon the way it is, with craters and mountains and valleys and bright parts and dark parts, etc. This was contradictory to the church teachings of the time. The moon was created by God, and whatever God created was perfect. You could not paint a smudge on the moon. He did. So he had to be abreast of different truths, the truth of the clergy, the truth of the ancients, the truth of science, the truth of taste, the truth of the theologians, etc. There were about 10 different kinds of truth. Which incidentally, it's not the last time that happened. During the Nazi era, there was a time when we had German physics, which meant that any research that had been performed by Jewish scientists was automatically disregarded. The Soviet had a people's biology developed by Lysenko in the 30s. Or just remember Orwell's 1984, or more recently, certain claims about alternative facts or fake news. One more project located in more modern times, in the future actually, was a different project by an artist from Berlin. She designs art for the long-term space traveler. She was in touch with the European Space Agency, and I believe also NASA, about the conditions spacemen would endure on their long-lasting missions to Mars, let's say. Mars is pretty far away. It takes about a year to get there. So the travelers would be confined with a few comrades in confined compartments. It will be a dangerous trip. And the artist wondered, what could art give them to make the trip more bearable for them? She came up with some pretty fancy designs. Okay, I will go through this no longer, but one thing I would like to say. I saw a remark on the internet the other day where somebody said, the way we think today, as different from 200 years ago, is largely determined by the work of two professions only, economists and engineers/scientists. That's how our mentality today is shaped. This was not so 200 years ago. Remember the arts, what was the influence of, let's say, hundreds of thousands of pictures of the crucifixion or of the nativity scene? This not influence our brains? And why? So artists had a huge power at that time. People like Michelangelo or Raphael or Tintoretto were not just super artists, they were stars. They had influence. Where are these such artists today? I mean, can you name one artist that had made history in the last 200 years? I think we're gradually getting to a point where we can do that. Because I think we understand the influence that art can have. It does not have today, but it can have if it really puts its mind to it. Yes, I'll leave it at that. Thank you very much.
Thank you.
Can I say one more thing? Just a short thing, because we're putting out a book. It's going to be called 50 Unasked Questions. And I would like to have your contributions for it if you feel like it. The idea is, in every field of science or research, there are certain basic assumptions that nobody ever questions. In astronomy, for instance, my son said that right away. In astronomy, for instance, you have analyses of how light is broken or shaped by light beams traveling through dust clouds. Now, how this light is refracted depends on the size of the particles. And the astronomers assume that the size of all particles in the whole universe is the same, which is obviously wrong. But it's these kind of assumptions that we're looking for. So if you want to write a nice article, understandable, about the assumptions in your field that nobody ever questions, please send me an email. Thank you.
It is an honor for me to introduce our next speaker. Heike Katharina Mertens is the director of the Sharing Stiftung, and she has given a lot of support in many ways. Thank you so much for being here and for having all the patience of the world, I think.
Well, good evening. I think everybody is longing for coffee, so I make it short. I'm very interested in who is an artist in this space here. And who is a natural scientist? Oh, okay, great. So, and everybody else is dealing with art and science as organizer or manager or as researcher. Well, I think you all already got to know a lot about our foundation. So I'm not sure, thanks. I just want to make some introduction of the foundation as the whole plan we do. We think that the most important thing on arts and science is freedom in research, either artistic research or also in the sciences is very important. And we named it yesterday that a lot of scientists actually changed during their studies to the arts because they got restrictions in their research and want to broaden their horizon. And since it doesn't work in all fields of the sciences, the arts often give a perspective on being more subjective and to give more influence to other things as bodily experience, bodily knowledge, intuition, and all these kinds that we already heard from many artists here and also from the projects we fund. I just want to make one point of the Sharing Foundation. We were established by the pharmaceutical company Sharing, but it doesn't exist anymore. So we are totally independent and not linked with Bayer, who bought Sharing in 2006. So these are sometimes confusing things, and we are often asked if we have something to do with that. And I'm glad we do not have so, because glyphosate, for example, is one of the topics we wouldn't like to have dealt with. And we also have a vision. We think both culture and science is very important in order to create a better society, in order to produce knowledge, and that's why we actually create a lot of formats where scientists and artists can meet. Here you have a template of our operational activities. The small part in the right corner is the funded project. This is like 50% of our work is giving money to other projects, such as class, but we do also run a lot of programs with partners. For example, a music parlor at the Komische Oper in Berlin, where we invite scientists in the field of the opera. So we take themes of operas and reflect them from the sciences. Or we have a project space that you have already seen on many pictures. Here on our roll-up, for example, is Pina Yoldas, an artist that Ingeborg Reichle just mentioned that she will be at the University in Vienna as a teacher soon. We also, there's one project that is not on the list because it's a funded project by us, not created by us, but it might be important also for this institute here. For example, we have a professorship at the University of Arts in Basel, which is a donated professorship, but not for a single person, but for many different persons that visit the university in order to give workshops, and they come mostly from the fields of natural sciences, because Chus Martinez, the head of the university, thinks that it's important also to teach natural scientists to the artists during their studies in order to understand what's going on. We do a lot of publications. We also created the NAPSE curatorial workshop, which is for curators to curate exhibitions in the interface of art and science, which is a special task, obviously. So there are a lot of questions occurring up in this field, and we did that for many years together with the House of the World Culture here in Berlin. You've already seen those projects, I will skip it. Just to make it more understandable what we are showing on our field, Pina Yoldas is a Turkish artist, and she was dealing with a great garbage patch in the Pacific Ocean. This is a plastiphore sphere with many microplastic particles on the surface of the ocean. And she was thinking, what if the primordial soup, where all life comes up from, where the bacteria was created, where we as human beings in the end came from, how would life look like if the primordial soup would already been a plastic soup? So this was the starting point of a huge project that she did, and she created organs that are able to metabolize plastics. For example, this here on the roll-up is a stomaximus with many different functions, specialized for different plastic sorts that can be metabolized by this stomach. Huh? Pina Yoldas, here on the top. She also created insects. All her sculptures are made from plastics. And the insects, for example, they're, because of the microplastic on the oceans, you have an additional surface where the insects can lay their eggs. So different species of insects come up, actually, that's the way it is. And she also developed many other creatures and insects that could live on this ocean. This was the setup in our project space. Just to give you one example, and one last one, and then I'm finished. Hannes Rickli, he might also be an interesting artist for the natural scientist among you, because he did it's one of the very seldom research projects that I know, which was run by an artist and not by a scientist. But in his group are many scientists, biologists from all over the world, also Hans-Jörg Reinberger, who has been here yesterday. And he did a project at the Alfred Wegener Institute for Polar Research. And he is listening to fishes, because the natural scientists at the Alfred Wegener Institute are listening to fishes. They have this sound mapping systems in Spitzbergen in the Arctic Sea to visualize the habitats of the fish there. And he reflects with his artistic research what kind of sound the scientists produce, what kind of data they are collecting, and how they do research on this data. And all these reflections came up to an exhibition and a publication. And this is quite an interesting field. It's an ongoing project funded by a lot of money from the Swiss government. And that might be someone to invite if you want to have a different perspective on your data. Yeah, thank you. And I think, will we have a panel now, or do we have a coffee? We have a coffee, okay.